Okay. Okay. Thanks, Pooja. Welcome everyone to Awkward Dev 149. Hopefully YouTube is working. If not, this is being recorded and I can upload it after. But yeah, a lot on the agenda today. I think high level, trying to figure out what Shanghai looks like is probably the main thing. And there's been some bunch of work on the EOF side, on the 4844 side. So we can share some updates on that. And then there were a lot of other EIPs that wanted to be considered for Shanghai. So I told all those people to show up today. So there's 4 main ones. Micah, you also had this agenda item about just talking about the fact that running a node is getting more resource heavy and that we should address that. So we can talk about that as well before the Shanghai inclusion conversation, so that we have that context. Assuming we get through all of this in less than 90 minutes, Mikhail had a quick engine API proposal that he wanted to discuss. And I think one thing that would be valuable is then talking about how we approach DevNets for Shanghai, if we have a good feeling for what's likely going into the fork. And then there are a few other topics, so mostly just how we think about sunsetting Ropsten and potentially testnets more generally, and some updates on execution specs and the tests generated for the execution layer. I guess to get started, last Friday there was an EOF call. Does anyone who was there want to give a quick update on sort of what was discussed and where things are at with EOF right now?
Tim, you broke up a little bit there. I don't know if that was just...
Sorry. Yeah, I was saying, does anyone here who was on the EOF call last Friday and want to give a quick update on where things are at with that?
And was I the only one there that's on this call?
I was there.
You're the first who spoke up, so Dano.
It's a game of chicken,
I was there
isn't
as
well. So a lot of it circled around the debate of big EOF versus little EOF. One of the big takeaways is we're going to target the Ethereum JS testnet Shandong, and we're going to try and target big EOF as our first and preferred approach to ship EOF. Shandong is a testnet. Tim wrote up a document showing that it's kind of on a parallel track. It depends on everything in Shanghai. May or may not include deposits or not for the testnet. But in essence, Shanghai is the most important, what's driving the release, which is deposits. And the other features, which would be 4844, which is parallel to the EOF, big EOF changes, depend on Shanghai. And the premise being, if we can get things proved and shown working on Shandong and tested and all the clients implementing it, then we could move it into Shanghai if it's early enough. And if it's not early enough, it moves out to Cancun. So that way we've decoupled development and validation of shipping it from whether it's part of Shanghai. So the discussion about deposits could be on a separate track. All we included in Big Shanghai was just relative jumps and function sanctions. We did not include the stack verification because that's still kind of in beta. So those are the only 2 big things we added into EOF, but those do change the nature of what the EOF container looks like. And because there was a desire to only do one major change in the next X number of years, we want everything that's in EOF big from everyone on the call, speaking for the people on the call. So let's just do it in EOF big and ship it as soon as it's possible.
I don't know if I missed this part, but I thought stack validation was part of EOF big. Like it's listed on the Epsilon EOF list.
So on the call, I think they said it was just not quite ready for implementation.
And the thing about stack validation is if we do everything else, you can still write code that validates the stack and you can still get the benefits of linear compilation with a subset of stuff. The validation API would just reject stuff that didn't match that. So that can be added later. And the real issue is it's not particularly specified in the specification way. It only has a reference implementation. So I think that's what's holding that one back.
I don't know. I mean, what do you mean it's not specified? There's the EIP. I've mostly implemented the EIP at this point.
The specification says is, check the stack height of each instruction. For something that's deterministic and repeatable, there would need to be an algorithm to find that this is what you do. And the algorithm that is in the reference implementation is actually not linear. It's like order n squared or something. And so there's better stuff. So it's not quite ready to ship would be the conclusion.
Okay. Yeah, I don't know what the timeline of making it ready to ship. It felt like to me that this is something that we can resolve relatively easily. Like all the other EOF EIPs have some small changes that need to be made just now that we're under this assumption of bigger EOF. And those are things that are straightforward. Whereas, if we don't ship the stack validation, we do have to increment another EOF version, since it would be possible to deploy contract code that stack overflows whenever you do a call up.
Can I just make a question here to dumb it down a bit? So whether or not stack can overflow or not. I'm thinking from pure EVM perspective, that's a pretty negligible check. Is it important from other points of views, such as verifiability and analysis?
So if done right, stack validation can allow for, per Greg Colvin, linear compilation time to transpile it to something like machine code. So if you can prove that, and that also provides a subset that then if you have stack validation, tools like Solidity and Yule can only create EOF, it can only create EVM code that can be linearly done. And it gets rid of a lot of compiler bomb attacks for people who are going to try and JIT it. Java's perfected some of this and brought it into their compiled process, and they've got the same rules on their JVM. It's really, there's a whole section on their spec about that. And that's, I think, one of the reasons why go ahead.
No, for any compiler, they can always validate the stack.
Yep.
Right. So what
that's my argument.
Is enforcing stack validation on contract deployment, which only makes a difference on runtime, or if you analyze live code on the blockchain, right?
If you reject, if you're going to be rejecting
that's
stuff that doesn't validate.
Are we going to reject stuff that doesn't validate, or are we not going to validate? From my perspective, as having building the EVM, I think the performance gain of knowing that the stack cannot be overflown is negligible. So therefore, I'm wondering, is there some other aspect to this problem where this actually makes a difference?
I kind of can concur why I don't think it has to be in. The Epsilon folk who are writing it, I think that was Powell. He kind of agreed that it wasn't quite done yet as far as the EIP. Yeah, there's a skeleton of a specification out there. There is reference implementation, but it's, he seemed to agree that it wasn't done and was happy with it slipping out.
Okay, that's fair. I think that it's just one additional thing that a small amount of work could make it so that it's ready. And we could avoid having, this immediate thing that we might want to make a version change to in the future.
Right. The train door is not closed on big EOF, but that's not what we're focusing on right now. If a finalized algorithm comes in that is linear and specified, that's what is needed to move it forward. And I think that's what he's working on.
Right. It's possible to add this to EOF devnets, basically, if it gets ready before Shanghai.
Right. Or whenever big EOF ships.
Right. Yeah. Andrew, you've had your hand up quite a while.
We briefly touched it on Friday, but I would like to highlight that one important task for the big EOF is supporting Solidity. So that would both verify that that the EOF makes sense and we can compile Solidity contracts into it, and also ensure that there will be some real contracts in production, because like I would like to avoid having it only as a theoretical thing that nobody uses. And to my mind, that's another thing, like not only implement it in all the EL clients, but have it like full good production level implementation in Solidity.
Yep, I concur. It does have small EOF support, which is relatively simple. So the big EOF splitting into functions is not a small compiler change. So,
I mean, if we're going to hold EOF to the standard, I think we should think about holding other EIPs to the standard. And I don't think that historically we have required a production level Solidity implementation for things. And I generally feel that a commitment from the Solidity team that this is a good thing, that they plan to implement it, is usually suffices.
The problem with that is that what kind of reiterating Marius's concern is that if we have something like if we accept EOF, that will be in the standard forever, and then Solidity commits to supporting it theoretically, then it turns out that because of some quirk of the EOF as is, they cannot fully support it and blah, blah, blah. So we'll have to have a new version of EOF, but the intermediate version stays there forever. So that's, to my mind, that's a very important change to the EVM. So we need to have sanity checks on it. One of the sanity checks. So I see Solidity support not as something, not as an extra, but as a sanity, an essential sanity check.
Can I just I mean, Alex Berexasi, isn't he both very involved in the EOF and very involved in Solidity?
yes.
And I think, I don't know if he or Chris, one of them is like the head of the Solidity dev. I think, I may be wrong here, which to my mind kind of speaks that, yeah, the Solidity team are probably very well, versed and aware in this proposal.
Yeah, and I believe Daniel is.
I would say that just awareness, well, at least that's my position, that awareness is not good enough. Like a working compiler into EOF without dynamic jumps is like, to my mind at least, it's like a requirement before releasing it to the mainnet.
And we kind of need it for testing anyway, so I would also really like to see it.
And I think, yeah, so I posted this in the chat, but generally I think the perspective was there, like they support it. The first few EOF EIPs didn't affect them much. The second ones obviously require more work, but they seem generally, supportive, although it's not clear like it's easy for them to support it. So we can definitely talk with them about it more, and I don't know that any one of them is on the call right now.
Respond to a comment like Plant made a bit ago that we don't hold other EVM changes. I think the difference here is that those other EVM changes are usually really small and everybody is quite confident that Solidity will have no problem implementing them. Whereas this change is quite substantial and there is non-trivial risk that Solidity will not be capable of implementing this reasonably. And so getting Solidity to implement this one first gives us that confidence that, oh no, there's no hidden gotchas or unknown unknowns anymore. Like it can and has been implemented Solidity. It mitigates all that risk.
Honestly, I was referring to 1153 whenever I mentioned this.
Oh, which one's 1153?
This is transient storage.
Oh, okay.
How does this kill 1153? I'm missing that.
Well, if we're going to require Solidity to have the implementation done in a production manner, there's no implementation of 1153 and Solidity, and it doesn't seem like there's intention of making an implementation in the near future.
Well, they
Got it.
I mean, I don't want to speak for them, but they did say that if it's approved and goes in, they will implement it.
Right, but now we're saying that
and
we're
also,
not going to approve things until it's implemented.
I
So
think there's a level of
but-
complexity that there's concern about on this other one. If there's a similar level of complexity of concern on 1153, then I would also maybe block on it, but I don't know if that's the
Well,
perception here. Chris, right, Wiesner did express concerns about the complexity on 1153. Unfortunately, he's
That
not on the
tells me to
call, I
block
guess.
it.
I mean, it's also implemented in Viper already, so it's a bit strange
Which one
to
is?
just index on 1153 is already in Viper.
T-store and T-load. It's much simpler than the container and getting rid of dynamic jumps.
I mean, to be clear, I don't feel a need to, it has to be Solidity, but I do kind of agree that we should see some compiler implement it successfully. And so if 1153 is implemented by Viper, for me personally, that kind of meets the bar of this has been proven that there's not a bunch of unknown unknowns that we need to worry about anymore.
Right. So I think, and you know, we don't have to make a final call about EOF or 1153 right now. I mostly just want to make sure everyone sort of knows where things are at. It probably makes sense to move on given how much time we've spent on this already. But at a high level, client teams are working on implementations for these 4 EIPs that we listed earlier. So the 2 original ones, 3540, 3670, and then the addition of 4200, 4750. The other one for stack validation, we have some implementations, but it still needs some work. And then Solidity support is obviously an open question. Anything else anyone wanted to share on EOF? Okay. I guess the next one I'd like to get a quick update on is just 4844. So I know there was a call this week for that as well. So yeah, does anyone here who was on the call want to share a quick update on where things are at?
I can give a short update,
Yeah,
and others can chime in if I miss anything. So on Tuesday, we had a 4844 implementers call. I believe the DevNet version 3 is on track, and we are targeting end of November, so after Thanksgiving. I believe the last crypto APIs have been merged, but then there's some open discussion on whether or not to share the precompile implementation as a whole, as a shared library, to not have to do the decoding of the points on the client side or like in the EVM implementation rather than in the crypto library. And then I believe Terence is tracking the open B2B changes on the consensus layer. There are some optimizations we can make there, specifically the branching part of the fork chest tree, where we can have many different beacon blocks. We have something called beacon block by root to fetch blocks on the existing beacon chain. And we may want an equivalent of that to fetch blobs. And then there's some discussion on whether or not to couple the beacon block and blob fetching with this by root method. And I believe those are all the big updates. Also, the EIP was updated with some parameter changes, which are still in discussion. And then going into the testnet and with the further testing of mainnet performance, of call data and so on, I think we get the data to decide on the parameters for 4844.
And specifically, I think the blobs by root is a blocker and the rebase on Capella is a blocker. Blobs by root, I think, generally has consensus and I expect to be merged soon, although there might be a finer point around how deep you serve those requests. And then the
Capella updates that are blocking the rebase being finished, we're going to wrap up today.
Thanks. And I think also, like on the last call when we discussed this, we mentioned trying to like iron out the final sort of design PRs in the EIP. I believe these have all been merged. So like the fee market changes have all been merged. And there was a PR also to change the output of the precompile. I'm not sure if it's been merged or not, but that might be the only outstanding PR on the EL side that affects the actual spec. I don't know, is Ansgar here?
I'm here.
Yeah, did you just want to get a quick update on just the PRs of the EIP itself?
Sure. So at least last evening I haven't had it. I only woke up for ACD, so I haven't had a look at it. But the precompile output change was not yet merged, but it's ready to merge. Right now, because of a small issue with the EIP repository, every PR to the EIP not only needs author approval, but also an EIP editor to actually merge it. So it's a little bit slower, but so basically there are 3 PRs at least that I was involved with. One is just a small change to so that the precompile, the point evaluation precompile, it used to only basically return like it just used to revert if it was invalid, or not revert if it was valid, but not return any values. And now it's supposed to return the degree of the polynomial and also the modulus of the field. So that's change 1. That's ready and just needs to be merged. Then there is a second change just to decrease the throughput of 4844. I think basically everyone agreed that if we, at least as long as we're still optimistically targeting Shanghai for 4844, we would want to start with lower throughputs, just so we don't have to worry about node load and network load. So that's still pending. And then there's a third one, which is basically a bit more open for discussion on whether or not we would want to introduce a minimum price for blobs higher than the theoretical minimum of basically one way per blob gas. That one is unclear whether or not people end up wanting to even do that, but that will also just be one constant change in the AP. So that's the 3 spec PRs that basically I have a view on.
Thanks. Any other questions, comments on 4844? Okay. I think, yeah, so the next thing I think it probably makes sense to cover is, Micah, you had a comment in the agenda addressing sort of the increasing operational costs of running a node. Do you want to take a few minutes and maybe walk through what you see as the issue? And yeah.
Sure. So to preface, I'll give a short little spiel to set the stage. My hope here is that we can walk out of this with a more consistent vision on kind of what we're trying to build. I feel like it's kind of fracturing a little bit, and so I do have a personal opinion on what I want, but I would rather see us be consistent on what we all want rather than any particular stance. So I think right now, if we round to the nearest integer, about 0% of users run their own node. And when I say users here, I mean people who are using Ethereum to do something. That might be buying and selling NFTs or trading tokens or whatever. This means that about 100% of users are using centralized services like Infura and Alchemy and whatnot. Many of those centralized services are actively censoring right now, like today. They censor people from a number of countries that really could use cryptocurrency, and they also censor a number of tools that are really good for privacy and stuff like that. And so we have this kind of censorship problem, and it's been slowly growing over time. And during that time, as it's kind of slowly kind of built up, we've been focusing a lot of our effort on scaling. And at the moment, there's lots of blockchains out there that focus on scaling. BSV, Solana, they focus on scaling, and they prioritize that over censorship resistant, meaning people being able to actually run a node. And so I feel like 4844 is kind of another step in that direction that we've been on, where we're prioritizing scaling at the cost of censorship resistance. In the case of 4844, this comes in the form of 4844 is going to increase the storage cost requirements of running a node and the network cost requirements of running a node. If this EIP to change it, 5863, or sorry, if this PR to change the throughput, that helps a little bit, but it is still strictly an increase. So 4844 is going to decrease the number of people who are capable of running their own Ethereum node from 0% to a smaller 0%. We do have some stuff on the back burner that's been working on very slowly, which is Merkle trees, statelessness, history expiry, state expiry. These things have been worked on for quite a while, but we keep prioritizing other things over them, unfortunately. And so they're taking a very long time to actually come to fruition and make it onto Ethereum. And during that time, you know, the size of the state continues to grow, the throughput continues to grow, gas prices or block gas limits have been increased a couple of times, I think, over the past few years, right? And we just keep kicking this can down the road. And I think that at some point we need to stop and ask ourselves, do we want a high scalability blockchain, or do we want a censorship resistant blockchain that people can actually run themselves? And if we choose that we want a censorship resistant blockchain that people can run, then I think we need to take steps to say, you know, anything that makes that situation worse, we should wait on until we have solved the problem of making it so people can actually run their own nodes, whether that's light clients or Piper's Portal Network or state expiry or history expiry or statelessness or Merkle trees or whatever that looks like. There's lots of options here. But I think that if we continue to not make the choice to prioritize those things, we're going to continue to make the choice to prioritize scalability. And that scalability comes at a cost. And we're paying the cost every time we do it, and it's a little bit at a time each time, right? So this 4844 is going to decrease or increase the operational cost a little bit. It's going to decrease the number of people who can run their own node a little bit. And this is the same as almost everything before, you know, increasing the block gas limit. It increases that operational cost a little bit, and these little bits just add up over time. So what I'd like to see us decide is, you know, do we want to kind of make the assertion that, yes, we understand that we're sacrificing censorship resistance for scalability, and that's an intentional choice we're making, and we do plan on fixing it, but not today? Or do we want to focus on censorship resistance today and sacrifice scalability and make that trade? So yeah, like I said, I have a personal preference. I'm pretty sure everybody here knows what it is, which is I care primarily about censorship resistance, but I'd at least like to see us kind of agree that we care more about scalability today than we do about that little bit of extra censorability that comes with 4844 and similar things. So that's my spiel. I'd love to spend some time talking about it, but I know we've got limited time, so I'll let Tim take it from here.
Thanks. Yeah, no, I think that was yeah. Appreciate all the context there. Yeah, let's just use the hands to go through the comments on this. So Andrew, you were first.
Yeah, from my perspective, we can do both. We can try to, to my mind, scalability is important, and we can reach better network participation with light clients version 2 or 3 or whatnot. But I would like to comment that to my mind, we can achieve both if we concentrate on fundamental improvements. So I would, for instance, in Aragon, we are still working on snapshot sync, and then it will allow us to support things like history expiry, or like, to be precise, more precise, IP 4.4s. But our capacity is limited, so I would rather avoid tweaking gas schedule or trying to optimize gas schedule things like 1153, which things that don't contribute either to scalability or censorship resistance, because they bog us down and we are not able to concentrate on making fundamental engineering improvements.
Thanks. Ansgar?
Yeah, I just wanted to say that I generally appreciate kind of Micah's sentiment. I think in our general course makes sense, kind of being pragmatic in compromising. I think we have a good long-term roadmap where the end state will be one where it will be very cheap and easy to run your own local nodes, and that is absolutely important. Like I would 100% agree on that. Like in the long run, the current situation would not be acceptable. But I do think that it is sensible to be willing to compromise to some extent in the short run for pragmatic reasons. And I think we're decent at this. I think, for example, with the current gas limit, there's a lot of headroom that we could have right now of increasing this, and we are not. I think, and that's the right choice. And then also with something like Point 4, it is explicitly designed to have constant cost for node operators. So there's no growth, which is the main problem with all the other load. So I think that makes a lot of sense. I would agree that, say, for 4.4s, a lot of people want this to be dependent on a fully decentralized history provider system being live before we would move forward with this. I think this is a big mistake. I think we can literally, like, once it's implemented, and I mean, as we just heard, of course, clients would need some time, but I think once it's implemented, I think we should just move forward with it because it would be the biggest gain for node operators. But again, basically, my point is, I think Ethereum's cause of being a bit dramatic in the short run, but having a very strong vision for the long run makes sense.
Thanks, Ansgar. Dankrad?
Yeah, so my first comment is like, I wonder in some ways if this is the right forum to discuss this, because this seems about like the strategic direction of Ethereum. So I feel like the right place to take this is the community and not a call of like the engineers. But since Mika brought it up, I do want to comment on it. And I think like my first most important comment is, I think like the current the resource consumption is not currently the main reason why people don't run Ethereum nodes. It's UX of all kinds. It is, of course, the state itself that you have to download that, which is a huge UX problem. But like this, I think 4844 is so marginal in terms of like for node operation at the moment. I mean, it will be very different once we have full statelessness. That I just don't see it as relevant. I don't think it changes much for people who run nodes. Most people don't run nodes because it's so much more convenient to use one of the centralized services, and not because they can't run a Raspberry Pi. And the other argument here is like, so what is decentralization, right? There's both like running a node, yes, but there's also using Ethereum. And right now, like the cost of using Ethereum is typically much higher than the cost of running a node. And that excludes much more users than the cost of running a node, which mainly is the UX problem, as I mentioned. So like I find it weird. And I think like Mika is like in a very like, I mean, I think already the Ethereum community, if you see it on a global scale, is on quite a strong position towards decentralization. Like very few other chains, if you look at them, are like care as strongly about decentralization as we do, which I do care. Like, I mean, I'm working on many projects to make this better. But the arguments like that Mika just brought are like in the absolute extreme direction, even within that community. And so like I feel like we have to be a bit more pragmatic here and prioritize people actually being able to use Ethereum.
Thanks. And yeah, Martin was saying in the chat basically the same thing with regards to the UX being the blocker rather than necessarily hardware requirements. Yeah, he had to jump, so I just wanted to share that. Lucas?
I have a question because my knowledge of L2 is limited, but would 4844 actually increase censorship resistance? Because you not only would have to censor like native Ethereum transactions, but also those blobs, which might be kind of hard to censor because they don't have like a fixed structure. That's the question. I don't know the answer.
I think it moves the opportunity for censorship to the L2 itself. So if an L2 is strongly anti-censorship, and they implement whatever's necessary to make that actually happen, then I suspect that the blobs, like you say, kind of makes it opaque instead of transparent. And so when someone adds just an L2's blob to the chain, it's much harder to notice that L2 is maybe doing something that is sanctioned or working with someone from a country that's not allowed to use Ethereum or whatever.
Yeah, exactly. And now when we're having multiple L2s, we increase the censorship resistance because you would have to censor all of them, right? Et cetera, to be actually censoring.
Yes, and this is, I would say that, I'll leave my comments till the end, so if anyone else wants to say something.
Bankrat, is your hand still up from the previous?
Oh, no, sorry.
Oh, good. Anyone else have any thoughts they want to share on this before Micah closes things? Okay, Micah, please.
So there's a couple of responses to a couple of the comments that were made there. So engineering is a finite resource. While we can theoretically work on multiple things in parallel, and we do, engineering resources that are put to other stuff is engineering resources that aren't being put towards censorship resistant stuff. And that includes things like UI, UX. Like someone could be building, Nethermind actually is, to be fair, working on their packager thing that packages beacon and execution layer together. But for every engineer they have implementing 4844, that's an engineer that's not doing something like that, whatever that other thing is. And so I think that we need to consider that this isn't just like 4844 specifically. This is anything that is not addressing the problem, is taking away those resources that could be addressing the problem. The other thing that I wanted to comment on was that this is minor, I'm not super convinced that the costs are prohibitive. I think for certain use cases, like if you're living in a third world country, you're probably not going to use Ethereum to buy your coffee, but maybe you could with a payment channel. But you might be okay to receive your salary every 2 weeks via Ethereum, and the fees are not so high that I think that's prohibitive, especially if it's just ETH. And then the last thing for the L2 situation, I generally agree that 4844 has potential to kind of help L2s along, and if L2s are censorship resistant, that helps Ethereum become censorship resistant. The problem is we currently have no L2s. If you define L2s as something that actually gets us security from Ethereum and is not censorable, currently every single L2 that is live, except for one which has 0 users, is centralized in some way, like it's got admin keys or backdoors or whatever. And so I'm hesitant to lean on we make L2s better and then all of a sudden our censorship problems go away, because currently no one has actually built and launched, I should say, an actually censorship resistant L2. And this has been like this for a year or two now, and they keep saying they're going to, and no one does. And so it's concerning to me to rely on that as a solution to this problem.
Thanks. I think one thing that's probably quite doable is everything that was mentioned around the UX of running the node. Sure, it does also require engineers to build this stuff, but it feels like it's probably more parallelizable because we don't necessarily need core client devs to do this type of work. So that's probably something that's worth exploring more. Are there different dev teams or contributors that can help with this specific problem that are sort of adjacent to client teams and not basically we're not as resource constrained on them. Anything else on this topic? Okay. Next kind of big thing is there were a couple more EIPs that people wanted to discuss with regards to Shanghai. There's 4 that kind of got mentioned. So high level, we had the self-destruct one, 1153, the transient storage, the BLS precompile, and then EIP 2294. I'm sorry, I don't have the title off the top of my head. But we can just go through them quickly in order. So is Jared here? I know Jared was looking into the self-destruct EIP. I don't think he's on the call. Does anyone have an update on the self-destruct EIP?
I'd like to make a suggestion about the self-destruct EIP. maybe we can list it as CFI for Shanghai because we are considering it. And to my mind, a good thing would be to have a blog post on Ethereum about that about self-destruct, that we are seriously considering it, and if any, and that dev developers who rely on this functionality should basically start screaming and highlighting their use cases, and then we can think about mitigations. Because if that there was one Pine contract, but if that one is dead, if nobody screams, then maybe it's not a big deal. If maybe we might disable certain contracts, but if they are dead anyway, then why not?
So there currently is at least one person who is screaming. Like, they're doing exactly what you want. We announced that we wanted to do this, and they are screaming, saying, "This is going to break my thing."
Can you? Is there a blog post or something? Can we actually check what the details of the smart contract and if there are potential mitigate? Oh, okay, I see the link. Okay.
Yep.
Okay.
I mean, one option is if this is the only person that screams, and we do some research, we find it's the only one. I mean, there is the option of just an irregular state change to fix that one as a potential workaround. And I think we asked them, and they said they would be fine with that. I might be mixing up my EIPs though.
I'm not fine with having an irregular state change to fix the contract.
No, but if I understand correctly, that person is also, I don't think we need a state change for this. He just, like, he's creating contracts and then self-destructing them in the same transaction. We don't need to actually change the state. That's, we just need to make sure that when self-destruct is being called during a contract creation, then it still works as it used to, basically. So there are paths around doing something as radical as a state change.
Are you sure this is the guy or the person who? I thought their self-destruct was in a different transaction from the create.
Yeah, I didn't check. I know of a guy called Rob M. He's working for some, I forgot the name of the thing. Yeah, I'm on mobile right now, so I can't check the link you sent.
And this person's name is Rob something else, so it feels likely it's the same one we're talking about. Maybe I'm just misunderstanding what his contract's doing.
Well, if that's not the same person, then we have two people screaming. But yeah, okay. Thanks for pointing that out.
So, does anyone disagree with the idea of like announcing to the community that this is something we're considering and having some sort of like outreach, both telling them to like post on ETH Magicians, but then also, maybe having some calls or whatever where we can discuss this and like understand what breaks and whatnot. Does anyone think like we should not do that? If not, so Ansgar had some comments in the chat about like moving this to CFI is probably premature, and we might want to like wait until we have a final spec to do that. So I think what I would probably recommend is quote unquote being louder. I don't know if like an EF blog post is the right way, but definitely like at the very least we can reach out to like a bunch of projects. Matt says he was looking at the list of all the contracts that sort of could be affected by this. We can then reach out to those contract creators if we can find them. So I think it is possible to do more on the outreach side than we've done. Yeah. Oh, sorry. Yeah, Jared said that. But yeah, I guess, yeah. Is there some objection to just doing that and then potentially updating the EIP with changes? And I don't know if this means we can do it for Shanghai or not, but at the very least, we can signal that we are going to be deprecating self-destruct, and try to accommodate, accommodate as many of the like edge cases as we can. Okay, no objection. So I'll take some time to look into that and follow up offline with Jared as well to try and reach out to all of the contracts that are affected. Okay, next up is 1153. So we have, I believe, a couple of the people who've been championing it on the call. Moody or Sarah, do either of you want to give a quick update about where things are at with 1153, and we can go from there.
I think Mark Timeway from Optimism is gonna lead.
Oh,
hey,
Mark,
yeah,
sorry.
I'm here. Cool. So, real quick, what is EIP 1153? It adds 2 new opcodes in this concept of transient storage. So there's T-store and T-load. And basically what transient storage is it's very similar to storage, but it is in memory. The 2 opcodes work exactly the same way as store and sload, except they write into this transient storage in memory. And this the storage only lasts for the duration of a transaction. It persists between call frames, which is different than regular memory, and it's namespaced by accounts, just like storage. And both of these opcodes cost 100 gas. So let's talk about the benefits that it provides. So one common use case would be using it for reentrancy locks. And let's look at the data for Uniswap v2 if Uni v2 is using transient storage for its reentrancy lock. So today on mainnet, between 1% to 2% of all the gas used is the Uniswap v2 router. And this the reentrancy lock has been triggered 26.7 million times in the last year. And with 2100 gas per S load, and we assume that there's an ETH price of 1100 and a gas price of 50 Gwei, that would switching to transient storage instead of using regular storage would save users 3 million USD or $3 million per year. And not only would it save users money, but it would also just save, disk lookups, like the hardware itself. We can also think about, if we designed some sort of DEX aggregator or AMM from scratch that uses transient storage. A lot of the accounting itself can be moved internally instead of having to do the accounting externally in contracts, updating their storage. So, for example, we can look at in Uniswap v3 trades that are that contain more than one swap. So they're kind of like multi-hop token trades. In the last year, there's been 2.1 million transactions with an average of 2.26 swaps per transaction. So what this basically means is we can remove calls in S stores from these intermediate tokens, and we can do all that accounting kind of like internally. And if we kind of naively look at Uniswap v3 using kind of this sort of style, we could have saved users like $1.15 million in the last year. And that's just looking at Uniswap v3. Like if you kind of really think from first principles and design a DEX aggregator or an AMM using this style, we think that we can make it extremely cheap to kind of do like these multi-hop token trades. Another thing is that the storage refund accounting is pretty complex and requires developers to do weird hacks. in kind of setting values from being set to unset. And it kind of is this like leaky abstraction. So we think that, if we can convince people to start using transient storage instead, we can start cleaning up the tech debt and moving away from the kind of these like hacks that developers have to do to save gas. And another interesting benefit is, and there wasn't consensus on this in Bogota, but I do believe that if self-destruct is banned, then when trying to parallelize execution, you only need to rely on the storage slots being touched. So if people start moving to a world where they use more transient storage instead of storage, especially for reentrancy locks, then I do believe that we will be able to parallelize more execution. And we understand that adding additional features to the EVM will result in like all of the ecosystem needing to upgrade their tooling. For example, like there's like a lot of formal verification stuff out there that will need to be upgraded and kind of take this new feature into account. But it's like not that different from storage. So it shouldn't be like, it shouldn't break all of the existing tooling in like a really crazy way. And just note that EOF will also require the tooling to be upgraded. And kind of as a final note, 1153 has already been implemented in Besu, Nethermind, Geth, and Ethereum JS. And there's a comprehensive integration test suite in the Ethereum test repo, and all of them pass it.
Thanks, Mark. Sorry. Okay, Andrew, you had your hand up for a while.
Yeah, I think in general it's a good EAP, but I see it as an example of gas schedule tweaking. So which might be okay, but we need to weigh costs versus benefits. If it's something trivial like warm Coinbase, sure, that's a no-brainer. It's a couple of lines of code, and it's easy. But here we have to prioritize it against fundamental improvements like EAP 4.4 or 4.8 4.4s, and because fundamentally, if we manage to decrease gas costs significantly, like I don't know, by 50 to 2 times or whatnot, that's a much bigger win than optimizing it by 2%. My 2 cents. And also it will say like, if we spend time on things 1153, then the more time we spend on things like that, the less time we spend on refactoring cleaning up, refactoring out code base, in making performance optimizations and so on.
Thanks, Dankrad.
Yeah, I mean, like, I don't know much about this particular EIP, but like the argument of like, oh, it makes reentrancy blocks easier just makes me wonder, is there a point that you get 80% of the value using something much simpler, like simply one flag you can set on a contract that's transient? Like, do you actually need to build a full-scale storage system, or is this complete overkill?
I would say that reentrancy locks are just an easy example, if you look at like Uniswap protocol design, you can do a lot of things to like say token transfers if you take advantage of transient storage. For example, when you do a multi-hop swap, that means like swapping across multiple pairs. You're not actually changing the overall token balance of the intermediate tokens in Uniswap. So you can completely get rid of those S stores and those calls to those intermediate tokens. If you take advantage of this transient storage, which is really just transient balance changes. So I think there's a lot of like real protocol innovation that can come from this, which will just open up a lot more block space on L1. And I don't think it's just like I don't see it as just a 2% increase in the block gas limit, it's that also like scales to L2s. L2s benefit from that additional block space, so it's anything that helps L1 just is multiplied by however much L2s can scale L1.
Thanks. Daniel?
Yeah, I just wanted to add something from Besso's side. So 1153 is one of the very, very few EIPs that has been implemented by external developers for us. And this is really something that does not happen a lot. And I would like the other clients maybe also to reconsider that they really did the hard work and not only just implemented a prototype for GAF, but also did it for minority clients. And I would like to use 1153 like as a role model to say to people, look, if you want your EIP included soon, maybe do the same. Maybe go to the minority clients as well, implement the prototype yourself. And like this, maybe we really, in the mid and long term, we really could gain because we get more external developers. And like this, we could really also get in more features per hard fork, simply by having more developer power on it.
Thanks. Yeah, I guess Moody or Mark, do you want to maybe just take a minute to talk about like, yeah, all the implementations? I know you briefly mentioned it at the start, but like, what's the state of the implementation across the different clients? And Sarah just shared also the PR to Ethereum/tests.
Yeah, totally. So I believe that Geth has an open PR right now. Between Besu and Nethermind, I believe one of them is merged and one of them is still open. The Ethereum JS PR has been merged for a while now. I do think one thing that we could do to kind of show that all the implementations are correct on top of having them pass the integration tests, which they already passed the integration tests, is running basically like a multi-client testnet. That's something that we haven't done, but that is what seems like the next logical step to do in kind of proving out that this works. We're also working on a fun little CTF that uses transient storage in a really interesting way that we plan on launching very soon on a testnet, just to kind of get something out there and show like what's possible with using these new opcodes. And we're hoping that, the community can have some fun, playing around with this and, solving this like on-chain puzzle.
Thanks. Dinkrat, again, I'm not sure if your hand was still up from last time. If so, then Lucas.
Yeah, just a quick here on the my point of view from this PR. So we merged the PR, but before that I managed to have a very detailed review, and actually there was some back and forth to like improve some things based on, I think, performance and our general. I'm not sure if there was like any, because it was some time ago, if there was any like issues with it or just like maybe just some smaller improvements. Would have to check. And I was also suggesting implementing some tests at some point, which were done, but I haven't validated them. So I would say the main effort here would be validating if this test suite, of course, apart from each client validating their own implementation, validating that this test suite is good in terms of its coverage, that it covers every edge case, and yeah, proving this with a testnet would also be helpful, like with external testnets. That would be another thing that would ease the burden. And so the question is more in, rather than like the throughput capacity problem of the engineers, is more if we generally want that to be included in VM, and potentially how well tested it is, rather than, which in my opinion is a good candidate for like some future improvement that instead of like if you really want something included and there is a consensus that we want to include this at some point, instead of like pushing everything on the core devs, if you can like actually provide value here by doing part of the work yourself and only leaving the validation to the core devs, that might be something good and something that actually helps the community, right? And yeah, that's it for me.
Thanks. And Marius, you had a different opinion about this in the chat, so please.
No, actually, I have a kind of the same opinion. What I just really want to make sure is that no one actually believes that like only because someone showed up and did the work that this change is going to go in. I think it's very important to validate every change on whether this is actually a good change, not whether it is ready. I think this change is actually a good change. I am not sure if it will increase testing, and it will make, if we want to schedule it in Shanghai, it will make Shanghai even harder to test, especially because we have like a lot of other EVM changes right now considered for inclusion, and all of these EVM changes kind of interact with each other, and so we need to test their interaction, and we need to test that everything is working. Just from the feeling I have is I would say it's not important, not as important as other changes, and it's not worth the increased testing effort and maybe the delay of Shanghai for. But I'm still on the fence, so I can also be convinced otherwise.
I guess, yeah, I'd be curious to hear just from client teams, like, it seems like the rough feeling is, people think this is generally useful. It's unclear, the relative benefit of this versus something else. But yeah, does anyone feel like we should basically give this precedence over something like EOF, which is probably the other big change for the EVM that's been considered for Shanghai? Because I can imagine, if we didn't do EOF in Shanghai, we could probably do this and vice versa. So I don't know. Yeah, I'm curious to hear from client teams if that's the right way to think about it, and if there's like a strong preference either way.
I don't have a preference or anything, but this is a lot smaller than EOF as a whole of EIPs. This is
right. Yeah. So yes, I agree with that. And I guess, yeah. Do you think? So say we did have EOF in, is your view that like we probably don't have space for something like this? Is that correct?
So I don't know what from Nevermind perspective, implementation is finished. So in terms of space for that, there's no problem. In terms of testing, I haven't validated the test cases. So if someone from core development would do that, that would give us more visibility, how much more is needed. There's definitely value in running a testnet with it. But yeah, that's my opinion. So it's hard to say how much effort that would be from the testing point, right? Because if the test cases are already robust, then there's little work.
Got it. Any other team have an opinion on this? Yeah, Daniel?
Yeah, I think from Besso's side is also mainly the testing effort that we will need to put up. As I said, there is already a PR I think we need to do some small changes to it, but more or less is ready. But it would mainly, from our side, be the additional testing effort. Nothing more.
I'm curious. Yeah, never mind. Sorry, not never mind. Aragon, Andrew. I know you were saying like this is probably less of a priority, and I don't know if there is an implementation in Aragon already. So is this something where like it would slow Aragon down significantly, or can you take also from Get what's been implemented there?
I think we can benefit from Get's implementation because our EVM implementation is still quite similar. Yeah, I mean, if kind of also on the fence. I would rather not do it, but if the majority wants to do it, then we will, of course, we'll implement it as well. Or let's say I would rather not do it in Shanghai.
Right, and I guess maybe this is like I don't know. It's hard to pre-commit to stuff in the next fork because things change a lot. But like, is this something that we should basically try and get alongside the dev nets we're building for Shanghai and see if we're happy with the testing and all of that, or should we basically soft agree to do it in the next fork, assuming we can test it and the implementations are there.
Yeah, I mean, this is Matt from basically to echo what Daniel was saying. I mean, as far as the minority clients are concerned, it's straightforward. I would love to see it included in the test networks, or at least in some specific multi-client tests, like we're standing up for withdrawals. So if the tests, if there's agreement that the tests are robust enough that were just shared, I don't see an issue with at least attempting, right? If it does add complexity in light of some of the other changes to the EVM or unforeseen things with these kind of test nets, it could be useful to push. But again, it just depends.
Okay, and so I guess Sarah, Moody, and Mark, you've been like doing a lot of work on this in the past few months, obviously. If we were to say like, let's try and add this to Shandong and see how multi-client testnets work and if we need to increase testing coverage, is that work that you can sort of own such that it's not like the core client teams who have to do the bulk of it?
Yeah, definitely.
Yeah. Absolutely.
Yeah. I guess I don't know, based on this, my feeling would be like we should probably make it CFI, add it to Shandong, and like see how the testing goes. And assuming it's a minimal effort on the part of client teams and we're happy with testing, we include it as part of Shanghai. If for whatever reason, we find the testing is too complicated, or that when interacting with EOF or whatever, there's some weird issue and we'd rather do EOF, we can always like remove it. But it seems like if like the Uniswap and Optimism teams are willing to help and like champion this, it's not really a ton of additional work for client teams. And it seems like everyone sort of wants this. It's just a question of, do we have the resources to do it? So does anyone disagree with that? So making it CFI, trying to get it in Shandong, and sort of reconsidering based on how well that goes.
I have like small issue with this because I will not be like from EVM1, I will not be able to have combined tests having this, because that's the way where the transit storage is placed is like kind of outside of the EVM API I have. So I wouldn't be able to participate in any like testing that has both features enabled.
So this would be just for EVM1?
Yes.
I don't have a good feeling
Could I ask, is that like an implementation thing we can help with?
I don't think so. Because like it's like on the client side to have that, so I kind of need to redesign the API that kind of plugins EVM. But it's like minor issue in the sense like EV1 doesn't like participate in the testnets, but if you like, it will be really annoying for me if the status like kind of have all the features suddenly enabled. I don't know how to like figure out the current testing with this, but
so
I can try to figure out later.
I guess, yeah, and I don't know. It feels like we've never really blocked something on that, and also just, yeah, it like especially because the commitment is just to move this to the test nets, and I would probably still lean towards doing it unless I don't know someone else have like a strong objection to that. Okay, so yeah, I say yeah, let's move 1153 to CFI. Try it on the testnet with the help from the Uniswap and Optimism folks, and you know, try and improve the test coverage as well. Yes, CFI. Yeah, we can see in the next couple of weeks how the devnets go and you know, if there's any issues that come up from there. And I think it's worth again reemphasizing, like, ideally this should take kind of minimal bandwidth from client teams, and if this is like a way we can get external contributors to bring your whole change in, that's a really valuable thing. So we should should try and get that done. Anything else on 1153?
Nothing else to add from our end, but yeah, thanks for, you know, making space for us.
Of course, yeah. And I assume you're all in the R&D Discord, but we can use the interop channel there to chat about this stuff and the devnets. Sweet. Next one on the list was we've talked about this many times in the past. BLS precompile 2537. There's like many different people championing this. Maybe Alex, I see. Yeah, you're on the call. Do you want to give a quick update of where things are at?
Me, Alex?
Yes.
There might be boxes. Yeah, everyone. So yeah, I think many of you have seen this EIP in the past. Essentially, it's adding BLS arithmetic to the EVM. There's like many reasons we'd want to do this. You know, we could have like more secure snarks. We could start verifying any messages from the consensus layer, which unlocks a ton of use cases around staking pools. Lots of good stuff like this. So yeah, I think historically there were some concerns around implementations, but I think those have pretty much all been resolved. Like if there's any like concerns around stability of the underlying code, you know, this stuff has been used on the consensus layer for many, you know, quite a while now. So yeah, so I think the question now is just like, do we want to push for this in Shanghai?
I think an important, so chains that use BLS, we could have light client support in mainnet. I think a very important second order effect is that EVM chains would likely adopt these changes, and thus the beacon chain could then be light cliented in there. It's kind of a weird reason to do it because it's, you know, the fact that it's on mainnet would then make it on other EVM chains, which makes mainnet interfacing with other EVM chains potentially safer, is the argument. But there's a lot of other essential use cases and reasons here, other than the fact that, you know, at this point, this is just a native Ethereum crypto curve that we can't natively use inside the EVM.
I guess, yeah, I'm curious from client teams, does anyone feel like this is something we should be prioritizing in Shanghai? Like obviously there's value here. we've been talking about it since the Berlin hard fork. Yeah, does anyone think this is one we should be prioritizing, given, I guess, the other things in Shanghai that we could be doing? Maris?
So I actually think this is more important than some of the other things in Shanghai. I would like, I think this is, it enables a good amount of new use cases. And I would say it's more important than things like EOF or 1153. But that's just my personal opinion. I'm from the kind of the testing perspective, this is way harder to test than some of the other changes, because it involves the, I think, 8 or 9 precompiles. And we have seen in the past issues with cryptographic libraries. We've seen in the past DOS issues. So all of these analysis, DOS analyses, are like very old at this point, so we need to rerun them. And yeah, so I kind of think it's very it's good, but I think it will, like, if we do this, then we will definitely delay Shanghai. Yeah, that's my general feeling.
Jared?
Hey, hi. I just wanted to chime in and say that I had drafted an EIP 5843 for expanded modular arithmetic in the EVM, and it's not really a competitor or to the 2537, but just chiming in to maybe ask for to just say that maybe we should consider something like this to potentially implement some of the cheaper operations that would be covered in 2537, just as a food for thought. And this EIP is something I've been working on for quite a bit and has been around. The idea has been around. It was previously called EVM 384 about 2 years ago. So yeah, just saying I've been working on that on and off, and just to add that in there to ask people to consider that as a route to maybe also get some of this functionality in the chain with little added overhead versus some of the precompiles.
Marius, is your hand up for another comment?
Yes. Yeah. A quick question. Which of the operations could be solved with? So right now, like the BLS EIP has, as I said, like 9 different precompiles, and if we could get that down to maybe only the pairing precompile and solve everything else with the mulmod stuff, I'd be really happy.
Yeah. So I was actually looking at I think my 5843 to answer the question from Alex in the chat. It's a draft. It's a draft of an EIP, and I can link more resources about it. But I guess in short, my understanding is that the elliptic curve, so scalar multiplication and addition, so G1 add, G2 add, and the G1, G2 mole would be fairly competitive. And I started to put together a doc about that I have not finished yet, but I can can try and release that fairly soon. I know, so there was an implementation of the pairing back in with the EVM 3D4 spec. But my understanding is that it's like significantly like on the order of 3 to 4 times slower than Blast. But I don't have a pairing implementation in the current spec. But I can put out some more information about this pretty soon.
So I feel we had a similar conversation when we were doing Berlin, and then BLS ended up not making it in because of potentially doing 384. Is that, I'm curious to hear from client teams, like, do people think that's still worth sort of waiting for, or at least, you know, and we can discuss this again in the next 2 weeks. We don't need to make a decision now. But yeah, I'm curious how strongly client teams feel about either way of BLS. Yeah, Guillaume.
I would say we're. I mean, the guest team. I think I speak for the guest team when I say we're not a big fan of adding more precompiles, simply because curves change, and if you have 9 precompiles that you have to keep maintaining forever, that might be a bit of a. I mean, it's not great. So I think it's worth at least digging, into EVM 384 and see if we can make it work in a reasonable time frame. I understand BLS is here to stay, but you never know. Like, the research keeps happening. That you get more newer ideas, better ideas. I think taking two extra weeks to consider it would not be wasted time.
Okay, Antonio.
Yeah, just quickly my opinion about what Guillaume said. I agree that the curves change. The point is, like, we're using this exact same curve in the consensus layer. So it's kind of, if it changes, we have if something in research happens that to make BLS 12.381 obsolete, we have a problem in any case, right? So so for the moment, we don't know. We think BLS 12.381 is the state-of-art curve, but so was BN in the past, and things change pretty quickly. But again, keep in mind that this curve is used in the consensus layer by all the clients at the moment.
Right. So I guess, yeah, just we're running against time. I think given that, it probably makes sense to, spend just 2 weeks looking at the potential EVM 384 upcode. Also, progressing on all of the other Shanghai stuff. And then, we can rediscuss this, I think, on the next call. Does that make sense? Any final comments on BLS? Okay, last EIP that someone wanted to bring on was EIP 2294, and Xingbelv is your handle. Hopefully I pronounced that right. Do you want to take a minute to talk about it?
Hey team, thanks everyone. So can you hear me, by the way?
Yes.
Yeah, so just want to quickly shed the light. This is EIP 2294 proposes a bound on the chain ID. I discovered this is because I was trying to implement something and realized that chain ID was not very specifically formalized in 155. And when I dig into the history, there's a bunch of it. And this seems to be a proposal for years. I like to know the context why it was not prioritized, and it seems a simple implementation, but can have a lot of benefit. Now, what adds to the urgency is that if we are envision a sharding chain world, chain ID will explode, and I wouldn't be surprised if people start to do things like cache something with chain ID. So adding a bounding as currently proposed by the previous EIP author, was bounding it under 200, under 64 bits. So you can imagine if some people start doing Kakash, is definitely going to break it. So want to ask people's thoughts about whether we should prioritize this, or I personally feel strongly about that we need to prioritize making at least a decision, and then whether it is 264 bits or 254 bits is up to debate. Yeah, thanks. I'm done speaking.
I think we don't really need to prioritize it. It's not a breaking consensus change. We can have a soft fork for it, and from my point of view, like, I don't see anyone being against this. If there's anyone against it, then they should speak up. But otherwise, we can just say, let's do it.
What do you mean by let's do it?
Let's implement it in the clients and just ship it whenever. Like, there's
Okay,
no
as a
need
soft
for
fork,
consensus.
yeah.
Yes.
Okay. So then, given we're going to be implementing a lot of stuff that needs consensus in the next few months, my suggestion would be we just talk about this in like 3 to 6 months when the Shanghai work is pretty much done.
Does this actually need to be talked about, other than just just people saying yes? Like, this is very similar, I believe, to the nonce limiting, where currently this is effectively already in place. We just need to make it official. Like, we need everybody to say yes, I agree, and then we're done, I think.
Yeah, exactly. That's what I wanted to say.
Yeah.
If there's no one disagreeing, then
I see people asking why it is 256 bits is because the word, but also the bound of 64 is that if it might not break the consensus layer, but it can break the application layer quite a lot because of how the nonce and the signatures were calculated. And yeah, just like in case people did agree without deeply thinking about it, I personally want to advocate it, but I hope that is a stronger consensus of yes.
I would include it into Shanghai, though it's not necessarily a protocol breaking change, just to track all the changes. So we can kind of loosely couple it with Shanghai for trackability.
But I guess the question is, should we do this now? Is it if it's trivial to do, then maybe, but in the chat, we're sort of discussing the fact that there's way too many things considered for Shanghai now. So is like putting that additional load on teams to do it. Yeah, we don't
all
need
agree
to
in this
ship
call
it.
to do it. That's it. There's no additional load on teams. Like, no one else has to do anything for Shanghai. We just say that officially this is the rule as of Shanghai, but I mean, it's effectively been the rule for all the time. Like, we could assert today that this was the case since the beginning of Ethereum. It's very similar to the nonce issue. We literally just need people to agree that yes, this is the thing. No work needs to be done. No code needs to be written. There's probably some places we could improve some code, but that's just tech debt that clients can pay down whenever they want.
Okay. Does anyone disagree with that?
Okay. So just because no one's used chain ID over 64 bits, we can't use it ever again? I mean, I see no value in limiting this, and don't see how it impacts mainnet.
Okay. Then, okay, given that we're at time, I think if there's like any amount of contention, we should just talk about it offline and try to, like, we can even make a decision offline once we're all on the same page. But yeah, we're already sort of at time.
And I'm guessing the only decision we need to make is 256 or 64.
Yeah, yeah. And once we've made that, then we can, yeah, we can just kind of signal it. But yeah, let's not have this conversation here. Yeah, and that sounds good. If you want to follow up with Dano, Marius, and Nika, that's probably the way to go. Okay, I think, yeah, so we're not going to have time to cover everything in the agenda. I think one thing that's probably worth covering is we discussed EOF and Forge 4.4 early in the call before the like CFI conversations. And like Client was saying, well, given what we're doing with the EOF EIPs, we should probably make them CFI 4200 and 4750. Does anyone disagree with? And actually, before that, the other part of the conversation from the chat is that it's probably unrealistic that we can do EOF 1153, BLS 4844, and withdrawals in one fork. So we probably need to prioritize for a subset of that, and we can spend most of the next call sort of discussing that. But yeah, generally, do people want to move either of these two EOF EAPs or 4844 to CFI? Do people strongly disagree with any of that? And if we can't get quick agreement, we can discuss this on the next call.
I'm not sure 4844 is in a place to be CFI yet.
Yeah. Okay. If anything is a bit contentious, let's not move it to CFI today then.
But I think we should move the EOF ones to CFI.
Yeah, I agree. I think because the consensus is that in favor of the big EOF, so they should either all be in CFI or none of them should be in CFI.
Okay. Does anyone, and to be clear though, there's the two I think we should move to CFI are 4200, 4750. Does anyone disagree with that?
I disagree. I see arguments to take all the EIPs and then force a decision where we only do one or two of them. But then I also see arguments that, okay, these are ready for CFI, so and so on. And as a result, I think the other EIPs do not get sufficient discussion and might never reach CFI just because of these forced decisions that we rush.
Okay. Anyone have another stronger opinion on this?
I think it's been clear for a long time that the stack validation's essential. So if we're not clear on that, I think we need to take it up at the next EOF breakout.
Yeah. Okay. So I think I would rather have this discussion next time with more time on the call. I think it's, we are working on 4200 and 4750. So I don't think them being CFI today changes how much progress is going to happen in the next 2 weeks on them. And yeah, I guess just for client teams and other folks to think about in the next 2 weeks, I think probably the main thing we should try and figure out in the other call is given the testing and implementation statuses of all the things we discussed today, what is the subset that we think is highest priority to consider for Shanghai? Yeah, and we can sort of spend more time discussing sort of these 5 or so things that we touched on today. And yeah, and then there were a bunch of links. So apologies we didn't get to them, but Mikhail had an Engine API spec improvement proposal. So if people can review that also before the next call, that would be great. I think for DevNets, we don't really need to change anything in the next 2 weeks. And one thing also that's probably worth it for client teams to look at is the new test framework that Mario put together. So this is linked in the agenda. And finally, on the other call, we should discuss a sunset date for Ropsten. So it's already been deprecated, but yeah, when we want to actually shut it down. But that can wait 2 weeks. Cool. Thanks, everyone, and see you all in 2 weeks.
Thank you.
Thank
you.
Bye.
Thanks, bye.
Thanks, bye, everyone.
Thanks, bye-bye.
Recording stopped.